My name is John Hobbs, and this is the course for Remote Snap Replication and Disaster Recovery for the MSA 1060, 2060, 2062, from here on referred to as simply Gen 6. So our learning objectives for today, to provide an overview of the Remote Snap Replication, describe the new features and functionality for the Gen 6, identify the components used in replication, describe the steps involved in the replication, and replicate a volume using either the command line interface, that is the CLI, or the storage management utility, the SMU. Our agenda is we'll start with an overview, including the background, prerequisites, components, and an introduction into how Remote Snap Replication works. We'll discuss some new features and a brief overview of the storage management utility. And then we'll talk about the ins and outs of remote replication itself, preparing the systems for replication, including licensing and checking for a peer connection, creating, modifying a replication set, initiating, scheduling replications, suspending and resuming a replication set, aborting replication, deleting and clearing a replication set or queue, showing the replication sets or the replication snapshot history, and deleting a replication set. Then for peer connections, we'll look at querying and creating a peer connection, setting and modifying the peer connection, showing the connections, and then deleting the peer connection. And then we'll cover the main part of this, which is disaster recovery, failover, failback, and reverse, and use cases. Now, this, if you'll notice that this deck does have 140 slides in it. We don't have that much time. So what we will do is, depending on your experience with the MSA Remote Snap from previous generations, and so I won't go into a lot of detail on the background and some of the ins and outs of how it works, but more of how to use it for the Gen 6. So an overview. What is Remote Snap Replication? It's array-based functionality for point-in-time replications of volumes or snapshots or volume groups. Using the existing snapshot technology, it knows which pages are allocated and uses redirect on write snapshots. It's licensed for and it can be used for disaster recovery or remote copy of data for development or patch testing. It's fault tolerant, uses either fiber channel or iSCSI for replication, and supports replication snapshot history, replicating existing snapshots, and limited replication queuing. So virtual storage, you've probably got this from previous courses in this series on the Gen 6. Disk groups are simply a collection of disks of the same type given redundancy mode. Tiers are one or more disk groups and defined by disk type of the disk group. Pools are simply a collection of tiers. Pages are the smallest amount of data, allocated, deallocated, or moved between disk groups in a tier or between tiers. Volumes and snapshots are provisioned from the pool, can reside anywhere in the pool, can utilize all tiers and all disk groups in the pool, and basically a volume or snapshot is a collection of pointers to allocated pages of storage. Volume groups, simply a collection of volumes used to more easily replicate multiple volumes simultaneously. And so here's a visualization of virtualized storage, even though the words in the document there, which may indicate, say, a page in memory, even though those words are sequential, they are scattered all over the storage, and that cylinder would represent tiers, disk groups, and as well as the whole pool. A snapshot is a point-in-time representation of data, uses redirect on write. So on write, a new page is allocated if necessary. Common data is referenced by both the parent and snapshot, and due to this, there is no loss of performance for snapshots, unlike copy on write. And so here's a quick visualization. We took a snapshot of the volume. So the snapshot and the volume look the same, refer to the same pages. And then we changed a few things in the volume, and you'll see then the with the red downward stripes, those are pages referenced only by the volume, and the purple upward stripes in the background are for pages referenced only by the snapshot. Prerequisites, we need two arrays, primary and secondary, a remote snap license, which is actually the Advanced Data Services license, Remote Snap, is included in that. A pool on each array, a primary volume, snapshot, or volume group, and at least one host port on the local side can communicate with at least one remote on the host port on the remote side. This does use fiber channel or iSCSI. For iSCSI, they must be connected to a network whose route tables and firewall allow iSCSI traffic, and for fiber channel, they should be in the same zone. Basically, just make sure that the host ports can communicate with each other. Peer connections. They're named connections using the host ports. Again, fiber channel or iSCSI only, not SAS. Can include any IO path they are used for communication as well as IO. They're bidirectional. You can have up to 4 for the 2060-2062, but only 1 for the 1060. And when you create or modify a peer connection, you need to supply a remote array username and password for a user on a remote system that has the managed role. Now, a replication set consists of a primary volume, a secondary volume, and a peer connection. This does have 3 internal snapshots, a current snapshot, a previous snapshot, and a queued snapshot. We'll talk more about those later. And once created, only the name, queue policy, and snapshot history configuration can be changed. So how does it work? Well, first we need to create a volume, and that'll become the primary volume on one of the arrays. Create a peer connection between the 2 arrays. Each array, again, must have a pool. Create the replication set using the peer connection and primary volume created above, and then initiate a replication on the replication set. Now, what happens during that time is the primary and secondary arrays save the current snapshots to their respective previous snapshots. The primary array resets the current snapshot of the primary volume so that it matches the contents of the primary volume by that time. The primary array then compares the current snapshot to the previous snapshot of the primary volume and copies the changes to the secondary current snapshot. For the initial replication, where there are no previous snapshots, all allocated pages of the primary volume are copied. This does use a push model rather than the pull model. Once the changes have been copied, the secondary volume is rolled back to the snapshot, and then if the replication set consists of a volume group, the secondary volumes are rolled back only after all the volumes in the volume group have been replicated. Now, new features for the MSA 2060, 2060, 2062, improved disaster recovery, but only when both arrays are Gen 6 arrays. First option, operation is failover, and this will fail over data access from the primary to the secondary. This does allow mapping on the secondary volume, but does not change the mapping on the primary, nor does it change the roles. Failback, when you're in the primary's failed over state, that fails back data access from the secondary back to the primary, and this takes 2 forms, either with restore, that restores data changes made to the secondary back to the primary, or failback no restore, which discards changes made to the secondary volume upon the next replication. Reverse is also available only when the replication set is in the failed over state, and this simply reverses the roles of the primary and secondary volumes. This does discard the changes made to the primary volume while failed over upon the next replication. Storage management utility. This is a new version of this SMU for Gen 6. It focuses on tasks. To perform a task, select the top level option from the menu pane on the left-hand side of the interface. That expands a drop-down list of menu choices. Then select the option from the list. Use the management pane on the right-hand side of the interface to select the volume, settings, or actions to perform. And once the top level and secondary option from the menu pane is selected, the management pane then becomes the quote-unquote panel for that option. Most of the replication tasks are performed in the volumes panel, and you'll be selecting provisioning and then volumes, and you'll get the panel over here that looks is the volumes panel. This presentation will outline options to select in the menu pane in purple and outline items to select in the management pane in yellow. We do have a number of icons new to the SMU. The slide over arrows are used to open and close panels that contain detailed information about an object and contain additional functionality. The information icon just opens a small window that defines or provides more information about a feature. If you see a pencil icon, then that means you can edit the item. If you like your changes, then you can apply it using the check mark in the green box or cancel it using the X in the cancel box. The primary replication volume is indicated by a folder with an arrow pointing up and out, indicating that the data is flowing out. Secondary replication volume is represented with a folder and the arrow going in, down and in, indicating that the data is coming into the secondary volume. Schedule looks like a little calendar, page out of a calendar, and then to suspend, you click the button that looks like a pause button. Resume looks like a play button, and abort or cancel is a X on a green circle. The limitations of SMU, of Remote Snap using the SMU. The only time that the SMU provides for creation of a schedule for a replication set is during the creation of the replication set. If you desire to create a schedule after that, then create the schedule and task using the CLI, and the schedule can be modified in the SMU. When manually initiating replication, the SMU does not provide a means to use the last snapshot or to specify a snapshot of the primary volume, but will instead reset the current snapshot at the start of the replication. If you want to specify a snapshot, use the CLI. Also, the SMU does not differentiate between replication history snapshots and regular snapshots. You can see that sort of differentiation in the CLI. And last but not least, the SMU cannot delete replication sets or peer connections when the connection between the arrays is down. To prepare the systems for replication, first we want to check out does it have a license. Here's an example of using the show license command. We're going to check to see that replication is enabled. For the SMU, we're going to use the install license panel. So we'll check maintenance, and then from the maintenance menu, check support, and then check the licensing tab. And since there's only one license available, we'll just check to see if the license is installed. If you need to install a license, you can use the SFTP or FTP and do a put with the file name license command. To use the SMU, again, we'll go to the license install license panel. We'll select browse for file. It will open up a dialog. You traverse the location of the license file and select that. When you come back to this dialog, the browse for file button becomes the upload file button. Click that, and that will upload and install the license. To check if a peer connection is viable, we need to provide a fiber channel worldwide name or ISO IP address, and then use the query command, peer connection command for the CLI or the SMU. Provide some examples of that. Here's the peer connection check for the CLI. You can see that it has a number of information about the system, and then all the licensing information, and then information about the controller, as well as which port on the remote side can be reached by which port on the local side. For the SMU, you select the settings menu, peer connection option, and then provide the peer connection, peer systems port address, and then select query peer connection. And what you get, it looks like this, a lot less information than you would get from the CLI. So if you want that connection, which port connects to which port sort of information, use the CLI. So the replication set itself, we create a replication set, and it consists of the peer connection primary volume and secondary volume. The primary volume must already exist. The secondary pool must also already exist. And again, we can use the CLI or the SMU. The SMU does have 4 ways of getting to the data protection configuration wizard, and we'll go over each of those 4 ways. And creating the replication set using the SMU does provide the ability to schedule replications or perform the initial replication once the set has been created. This is just some limitations and descriptions of replication sets. These have not changed. And continuing on, this slide is basically talking about since we're going to be creating volumes and volume groups on the secondary, those volumes or volume groups or volumes or volumes groups with those names cannot already exist. Again, we do have 3 internal snapshots. They are not displayed by default in any of the interfaces. They do not count against the license limits, but they do count consume space, and they do count against overall limits. Once the replication set is created, none of the volumes in the replication set can be deleted. And then in normal operations, secondary volumes cannot be mapped but can be snapped, and then you can use that snapshot to map it to a host, and the snapshot of the volume can also be reset to the current contents of the secondary volume. Now, if the replication set is failed over, that's one of the new features. The replication volume, secondary volumes can be mapped. And then this is some more information about replication sets. While the primary volume may be expanded and those changes will be reflected in secondary volume, the secondary volumes may not be expanded directly. You can see the roles of your primary and secondary volumes in the show volumes details CLI command. And then you also are able to set a queue policy to either queue a replication if another replication is already in progress, or to discard the requested replication. And this slide is about snapshot history. Again, this has not changed, and basically talks about how the snapshots, the various different things you can configure for snapshot history parameters. Some more information about the snapshot history. Again, manually created snapshots and snapshot history snapshots are 2 different things. Only the snapshot history snapshots are managed by the snapshot history feature. Manually created snapshots are not. And also, this is not available for volume groups. Replication snapshot history is only for volumes. So we'll see on the replication and other visualization that when we create this, the secondary volume, current snapshot, and previous snapshot are created. The volume creates a snapshot for the current snapshot and the previous snapshot off of its empty volume. And then on the primary side, the current snapshot and previous snapshots are created, reflecting the current values of the volume at the time. To create a replication set using the CLI, remember that we do need an existing peer connection. We'll see how to create that in the peer connection section later. And here's an example. Here's an example for the SMU. Again, we'll do provisioning volumes to get to the volumes panel. Once there, we can select one or more volumes from the volumes table, then click select volume action and choose add data protection. That's the first way of getting to the data protection configuration wizard. The second way of getting to the data protection configuration wizard is from, again, the volumes panel, and this time we'll select a slide over for the volume, and that will bring up this detailed panel, and we'll select the replications tab and then add data protection. The third way, and this is probably the way that offers the most options when you get into the wizard, is again from the volumes panel. This time we will look in the data protection table view. So we'll select that. We'll see volumes that are protected currently in the table. Then we'll simply add data protection, and it will allow us to then choose volumes and the type of data protection. The last way of getting into the data protection configuration wizard is to, again, go to the volumes panel, stay in the volumes view for the time being, select one or more volumes, and then select the data protection table view, and then do the select volume action and add data protection from there. So this is a lot like the first way of doing it, but just kind of one way just to show you how it's different. Then you get into finally the data protection configuration wizard. Now those 4 different ways are just ways of getting in here. This particular display is from the add data protection from the data protection tables view. And you can see that because we didn't select anything specific yet, we need to tell it which type of data protection we're going to use, remote replication or local snapshots. And then we are able to, at this point in time, choose the volumes. Now, if you'd already selected volumes and then hit, add data protection, then some of this will already be done for you, and you cannot, select it for you as it were, or your own selections, and you cannot change it. If you are able to change it, obviously, do the select of the remote locations and the volumes, and then hit continue. And then we need to, at this point in time, either use an existing peer connection or create a new one. If you do not have an existing peer connection, you will not see this option. It'll take you to something that looks like the next slide. If you do want to create a new peer connection, that again will be in the next slide. So in this slide, we're looking at creating a new peer connection. So we're going to enter the port address and then click connect. And then once it is validated that the peer connection can exist, we need to provide it a name and then a username and password for a user on the remote system that has a managed role. And then we select create peer connection. And then at the end of that, we will get a confirmation screen, and then we'll just hit continue. If you did have an existing peer connection and you want to use it, you can say select the existing peer connection, and then from the choose peer menu, select the connection you want to choose, and then hit the continue button. Data protection configuration wizard. For setting the replications, now that you have your peer connection set up, you will need to specify the parameters for the replication set itself. That includes the name, that's required. You can change the secondary volume name if it's a replication set of a volume but not a volume group. Choose the pool and the queue policy. And then lower down on that dialog, we have the second remote snapshot history. And you can select either to perform this history on the secondary volume only, or if you want to, secondary volume and the primary volume. Specify the snapshot count, how many snapshots to retain, and then the base name. And finally, the retention priority, and that applies only to snapshot space, not to the count. Once you've supplied all this information, click continue. And at this point in time, you have the option of either replicating the volume immediately upon creation of the snapshot replication set, or to create a new schedule. But you have to choose at least one of these. You can choose both. So in this case, I've chosen to create the schedule, which opens up the replication schedule part of this dialog. Provide a name, and you can select at this point in time if you want to use the last snapshot for that volume to use as replication instead of resetting the current snapshot. You specify the schedule start time and whether or not you want it to repeat, and then when it should end and the date and time constraints, and then click continue. And so at the end, you'll get the summary, select apply, and your replication set has been created. Now to set or modify a replication set, we can use the CLI command set replication set or the SMU. We will be using the replication tab, which we saw earlier when we were going to create a replication set in some of these settings. Attempting to modify the snapshot history retention count below the current number of snapshots will fail. You need to manually reduce the number of snapshots before reducing the retention count. And then changing the queue policy while the replication is running will affect subsequent replications, but not the current one. And so here's the CLI example. For the SMU, again, you're in the volumes panel. And so either from the volumes view, you select a slide over button for a particular volume, or if you're in the data protection table view, you click a slide over button for one of the volumes in the data protection table. And in this case, you can see that I've already changed the replication set name, and I'm in the midst of changing the snapshot count. If I like that count, I would click the green check mark on the green box, and then we come up with our first learning check. When this replication set is not failed over, secondary volumes cannot be mapped, but they can be snapped. Which of the following applies to snapshots of secondary volumes? And select all that apply. Okay. Yes, the snapshot of the secondary volume can be mapped to a host using any access mode, and the snapshot can be reset to the current contents of the secondary volume, but you cannot use that secondary snapshot to roll back the secondary volume. That would be modifying the secondary volume outside of the scope of replication, and that's not allowed. Next learning check. When creating a replication set, which component or components must not exist and will be created as part of the process of creating the replication set? Okay. Answer is the secondary volume or volume group, the primary volume or volume group, that must exist, and the peer connection must exist. Now, when we want to initiate a replication, we can use the CLI replicate command, or using the SMU, again, we're going to go to that replications tab. A replication may only be initiated on the array contained in primary volume, and then if a problem does occur, the array suspends the replication, and it will attempt to resume the replication every 10 minutes for the first hour, and then every hour until replication resumes. A suspended replication set may be aborted. A running replication set that may also be manually suspended. And this just describes what happens when you initiate the replication for initial replication and subsequent replication. And again, we may choose to replicate the last snapshot or a specific existing snapshot rather than reset or create a new snapshot for the replication. And that is, again, available only on the CLI, not the SMU. And again, those kinds of snapshots apply only to volumes, not to the replication set of a volume. So you can't specify the last snapshot, say, for example, for a volume group. And so we have a quick example of what the initial replication looks like. In this case, we've changed some things in the volume since the time that replication set was created. So not everything in the volume is in the previous snapshot, for example, but when we snap that volume into the current snapshot, it matches at that point. And then for initial replication, we simply replicate from the current snapshot of the primary to the current snapshot of secondary. And then we roll back to secondary. Now in between replications, I'm showing that here that we've changed some things around again. And some of these are referenced, some of these pages then are referenced only by the volume. Some of them are referenced only by the snapshots. So on a subsequent replication, you copy the current snapshot down to the previous snapshot on both sides. reset the current snapshot to be the contents of the current volume. Look at the differences between the current snapshot and the previous snapshot, copy those changes over to the secondary current snapshot. And I wanted to point out here that if you've removed a page, what we do is we simply copy zeros over for that page, and a background task on the secondary side will gather those pages that are all zeros and be able to reuse those pages as real data. So it reabsorbs that into available data space. And then at the end of the replication, you roll back the volume to the current snapshot, effectively matching the volume to the current snapshot. And here's how you do that in the CLI. In this case, we are showing that it is using a VSS snapshot. And then in the SMU, again, the volumes table or panel, you get to open a slide over for one of the volumes, either in the volumes table itself view or the protection table view, and then replications tab, and then click the start replication button. Now again, if you want to schedule a replication, you can do so by creating a task and schedule in the CLI. Again, the SMU does not provide for creation of a schedule for an existing replication set. If you want to create one, create it using the CLI, and then you can modify it in the SMU. And the replication may only be scheduled on the array containing the primary volume. And then there's some information about what happens if an existing replication is already running. That depends on the queue policy. So another learning check. You may replicate the last snapshot or a specific existing snapshot rather than create a new snapshot for replication. This applies only to which... Okay. Yes, that is correct. You can only do this for the replication set of a volume, not to the replication set of a volume group. All right, peer connections. See the preparing the system for replication to check for the viability of a peer connection. We've already discussed that a while back. And then see the replication set section for information about how to create the peer connection using an SMU. There is no other way of creating a peer connection in the SMU other than while you create the replication set itself. Using the CLI, use this create peer connection CLI command. This takes a fiber channel worldwide name or iSCSI IP address. At most, 2 paths will be used. Optimized paths will be used until depleted or until they fail. Only then will unoptimized paths be used, and if CHAP is desired, set the CHAP secret to be the same on each array and enable CHAP on each array. Here's an example in the CLI. In this case, I chose to, instead of entering the password on the command line, allow the system to prompt me for the password. You can change or reset the connection with a new remote address, either using the CLI or the SMU. If you do reset the connection using a remote address, that's exclusive. You cannot change the name if resetting the connection. Resetting the connection is only available when all replication sets using the peer connection are suspended and aborted, and non-running replications sets are simply suspended. And again, 2 paths will be used and with the same optimization limitations. If you're, on the other hand, changing only the name, then replications can continue since the connection itself is not reset. And then as with creating a peer connection, this operation does require the name and password of a user on the remote array that has the manage role. And here's an example of how to do that in the CLI. And on the SMU, you select the settings menu, peer connections, and then you select the edit button. That fills out the bottom part of this, and you can change which you want to, one of the two, either the name or the peer connection address. Supply the address if you're going to change the address, And again, it requires remote username and password, and then simply click apply. You can show peer connections in the CLI or in the SMU. Here's a CLI example. Again, you can see how it provides quite a bit of information about which local port is reachable by a remote port. Doing this with the SMU, you can see, go through the same, to get to the same peer connections panel. Underneath the current peer connections, you can just see what the local ports are and what the remote ports are, but you do not see the individual, which port connects to which port. To delete a peer connection, you can use the CLI command or the SMU. This is only possible when there are no replication sets using the peer connection. And if no connection is available between the arrays, you can run the delete peer connection CLI command with a local only parameter, but that's not available when in the SMU. So I show in this CLI command example that we are using the local only parameter, and to delete it in the peer connections panel, select settings, then peer connections, and then you select the trash can icon, which will delete that peer connection. Here's learning check for peer connections. Changing the name of a peer connection will not impact a replication in progress that uses the peer connection. Is that true or false? Okay, that is true. Changing only the name does not impact a replication in progress. Another learning check. If resetting the connection using a new remote address, select all that apply. And we find out that all of them do apply. That is exclusive. Running replication sets must have, using that peer connection must be aborted. And again, we have the 2 paths limitation on a peer connection. Now for the meat of the presentation is disaster recovery. So now if the primary array fails, or if it is inaccessible to hosts, there are a number of actions possible to recover access to the data and to recover the replication set. Now these improved disaster recovery options apply only when both arrays are Gen 6 arrays. These operations are available from the CLI only, and the main operations are failover, and that again fails over to the secondary volume, allowing write access to that volume without altering the replication set, and then you can either fail back to the primary volume, retaining changes made to the secondary if desired, and retaining the roles of the volumes in the replication set, or reverse the replication, exchanging the roles between the volumes in the replication set. First operation, failover. Now you run this operation on the secondary system. Why? Well, we're assuming that the primary systems failed, so we need to be able to run it on the secondary system. And that moves replication set into the failed over state. This is not allowed if it's already in the failed over state, or if an initial replication has not occurred. Because if that initial replication has not occurred, you have nothing to fail over to. This does allow mapping and accessing the secondary volume. All scheduled or current replications of the replication set will cease. The contents of the secondary volume are the result of the last successful replication. If you so choose, you can roll back that secondary volume. For example, if the primary volume was corrupted by a virus or an unwanted update that had occurred, so you can roll that back to any of your history snapshots, for example. You can also create a snapshot of the secondary volume before modifying it to preserve its contents, especially if you're not using a snapshot history. You may not need to do that, but that's available for you if you want to. And then while failed over, both the volumes or volume groups continue to have the same roles, either primary or secondary, as before. This also does not change the mapping of the primary volume. The primary volume retains its mapping as it was before the failover. Here's an example in the CLI. property to look for in the CLI output I've underlined. So we're doing a show replication sets to see that the status is ready. Then we run the recover replication set with a failover operation. And then we see that the status has changed to failed over. Once in the failed over state, you can, if you want to, choose to fail back the replication set. This is only available in the failed over state, and this operation again has two modes depending on if you want to restore the changes made to the secondary volume while the replication set was failed over, or discard those changes made to the secondary volume. Both peers must be operational, both arrays healthy and communicating. And we look at failback restore first. This is the most complex of them. Failback restore restores changes made to the secondary volume while failed over back to the primary volume. It's a two-step operation. First, you run the command on the secondary array. Now at that point in time, it unmaps the primary and secondary volumes, puts the replication set into a temporary failback restore state, which can be seen in the failback in progress column in the show replication set CLI command. Now this temporarily reverses the direction of the replication set, but only temporarily. This initiates a replication from the secondary volume back to the primary volume. This will discard changes made to the primary volume since the last replication. When the replication is complete, the replication set is no longer in the failed over state. The second thing you do is run this on the primary array. Now this reverses direction of the replication set back to the normal direction. And that does remove the replication restore state from the replication set. I've shown also in this slide some events that you might see when you're performing these operations. So the CLI example for this, we're going to again show the replication sets to see that the status is failed over and the failback in progress is false. We're going to recover the replication set using the failback restore operation. Now this will ask us a couple of questions because this will modify the data on the primary side, any data that has changed since the last replication. Once we've answered those questions appropriately, we can see that the status is now ready and the failback in progress is true. Now, if you were quick enough to catch this while that replication was occurring from the secondary back to the primary, you might see the status is running. At this point in time, what we do is we go back to once the replication set is back in a ready state, we go to the primary array, we run the recover replication set with the failback restore operation on that primary array. Now, since all the data modification, if there was any, has already taken place, all that it's going to ask you is a simple, do you really want to do this, yes or no? And we'll see that the status then, failback in progress goes from true to the failback in progress status goes to false. So what happens if you have a failure during this replication from the secondary back to the primary? If during that first stage, a failure occurs either on a peer connection or the primary volume system prevents the completion of the replication from the secondary back to the primary, your replication set will have an unknown status. The run error or for replication states that the replication has been suspended. You will see an event. You may want to access and modify the secondary volume because you can't afford to be down. You still want to be able to use that. But because you're in the replication failback in progress, you cannot map the volume. So what do? You simply leave the replication set in a suspended state, create a snapshot of the secondary volume, map that snapshot, and mount it on a host. You can modify it as you desire. And then when the failure has resolved, allow the replication to continue. And you may want to resume it to quicken the process. Remember that it only checks every 10 minutes and maybe even every hour to see if it can resume it automatically. Once that has completed, you unmount the snapshot from the host, unmap it, and then you roll back the volume to the snapshot. So now you're getting all those changes back into the volume. And then you initiate another replication to finish updating the primary volume. Again, you do this on the secondary side because it's temporarily the primary volume. But you initiate this replication to finish updating the original primary volume, and then you run the restore operation on the primary volume system to complete the failback. Failback no restore, a lot simpler. This simply discards changes made to the secondary volume while it was failed over. It does unmap the secondary volume, keeps the mapping of the primary volume in place. This moves the replication set out of the failed over state. It does discard changes made to the secondary volume while in the failed over state upon the next replication. And so we see an example of that. We show the replication sets to see that the status is failed over. Again, when we run this recover replication set using the failback no restore operation, we will get a couple of questions because this will possibly modify data on the secondary volume. And when you get done, your status has become ready from the failed over status. Reverse, this is also available only when the replication set is in the failed over state. This simply reverses the roles of the primary and secondary volumes. Again, peers must be operational with both arrays healthy and communicating. This does unmap the original primary, soon to be the secondary volume, and it moves this replication set out of the failed over state. This will discard the changes made to the primary volume while in failed over state immediately, or actually all the changes made since the last replication, and updates with changes made to secondary volume upon the next replication. And here's an example of that. Again, we see that status has failed over. We're asked a couple questions because this will possibly modify data on what was the primary and will become the secondary. And we'll see that the status then, after all is said and done, is ready. So some learning checks for replication sets in the can a replication set change direction? Okay. Is it true or false? False. This was true. A replication cannot change directions in previous generations of the MSA, but the Gen 6 does allow reversing using disaster recovery recover replication set command. Next learning check, what operations copies the changes made to the secondary volume while failed over back to the primary volume? And more than one may apply. Okay, most of you got it right. The operations are failback restore, that copies those changes back immediately, and then reverse does the same thing, but later when the first replication in the new direction is run. Last learning check, you can run the failback operation only after this replication set status has already failed over and the peer connection status is online. Is that true or false? And that is true. You have to be failed over and the connection has to be online. Now, a quick look at some use cases. We've just talked about disaster recovery. That's a great use case for the new features. You can use the remote snap replication as a cost-effective means to maintain a copy of data at a remote location. Now, this does support manual disaster recovery only. Is not integrated with third-party disaster recovery software, although there is an SRA for VMware's SRM. To access the replicated data at the secondary array, you can either create a snapshot of the volume or use a replication history snapshot and then map that snapshot, or preferable, fail over the replication set and map and mount the snapshot, or the secondary volume directly. Now, depending on the state of the primary volume when the primary array becomes available, you have the option to either fail back the replication set using this data from the secondary. You can fail back discarding the changes at the secondary. You can reverse the replication set and now using the secondary as a primary. Or if the volume on the primary side did not come back up, you can delete the replication set entirely and then rebuild it using the secondary as a primary. Now, if speed during failover is really important, then what you might want to do is map a snapshot, whether a manually created one or a replication history snapshot, to a host. After each replication, you unmount that snapshot, unmap it, reset it, and then remap it and remount it to the host. That way, when disaster strikes, the latest replicated data is already available to the host. You can use remote snap replication for software development because, for example, you may need to test real data, but you don't want to test your code on the data that your business actually runs on. One option is to create a snapshot of the data and test your code development on that. But both your development team and business applications are accessing the same array, and that may result in a performance issue. Also, your development team may be at a remote location that would also may result in performance issue accessing the data remotely. The solution is to perform a replication using the following steps. Quiesce the business applications, begin the replication. Once it's started, then you can resume the business applications. Once the replication set completes, you can use the remote copy to develop and test code using real data, just not live data. You may want to schedule the replications to occur at regular intervals to reflect changing conditions in the live data, but remember to quiesce the business applications before the replications start to provide an application consistent copy. And finally, you might want to use remote snap replication for patch testing, very similar to the code development. But in this case, you might want to test patches from, say, for example, a boot volume. So you want to start the replication set during a maintenance window when everything's fairly quiesced. Once the replication has started, you can bring things back up. Use remote copy to test the patches using a real boot volume. It's just not the live boot volume that you might be using. Schedule replications to occur to reflect changing conditions in that boot volume. When patch testing is complete, then you can fail over and fail back or create a new replication set using a snapshot of the secondary volume. And then finally, you can just boot either from the original boot volume or from a second snapshot of secondary volume on the live array. And that's the end of the course.